Hello, we're going to cover the domain of a function raised to the power of another function. We will discuss 3 examples. Let's start with the easiest of all. On this example, we can see some kind of exponential function. X minus 4 is the base, and 5 times x minus 2 is the exponent. Based on the study of exponential functions, we know that the base must be a positive number, so x minus 4 must be greater than 0. Solving the inequality and representing it on the number line, we get the region in which this function is positive, which is the open interval for positive infinity. Remember that we use hollow circles and parentheses when the endpoints are not included. Now we have to consider the exponent. So you can see the exponent is a polynomial function, and of course polynomial functions are defined for all real numbers of the variable x, from negative infinity to positive infinity. We are dealing with a combination of 2 functions, so the domain of the whole thing will have to be the intersection of the domains of both functions. This involves identifying the common regions where both functions are defined, which is here. And the domain we were looking for is the open interval for infinity. It was easy. Let's go to the next example. In this case, the base function is a little bit more complicated, but it still has to be greater than 0. Maybe we need to review how to solve rational inequalities. First, we will set both numerator and denominator equal to 0 to find the points of interest. We want these points because the behavior of the function may undergo significant changes. Now we have 3 regions on the number line, and we're going to evaluate the sign of the function on each of those sections. Let's pick a number between negative infinity and 1, for instance, 0. 0 minus 4 over 0 minus 1 is minus 4 over minus 1, which is 4 positive. We'll do the same with a number between 1 and 4, for instance, 2. 2 minus 4 over 2 minus 1 is minus 2 over positive 1, which is minus 2, negative. And finally, we will consider a number between 4 and positive infinity. 5 will do. 5 minus 4 over 5 minus 1. That's 1/4, which is positive 2. Okay, so the portions of the number line where the function's value is positive will be included in the domain. But what about points 1 and 4? When x is 0, we get 4 minus 4 over 4 minus 1, which is 0 over 3, 0. The base has to be greater than 0, not 0. That's why 4 is a hollow point. When x is 1, we have 1 minus 4 over 1 minus 1. This is minus 3 over 0. This means hollow point, because dividing by 0 is not allowed in mathematics. So the domain for the base function is negative infinity, 1, open interval, union, 4, open as well, positive infinity. Now we have to deal with the exponent. It's a polynomial function, so the domain is all real numbers, from negative infinity to positive infinity. The intersection of the domains will give us the domain of f of x. We've got it. Next example. The base has to be greater than 0, and we've already calculated the domain. which was this one. Now let's focus on the exponent. We have one polynomial in the numerator and one polynomial in the denominator. In this case, the only problem that can arise is when the denominator becomes 0, because, as you know, division by 0 is undefined. So to find the domain of this expression, we need to find the x values for which the denominator is 0. Setting this to 0, we know that minus 3 has to be excluded from the domain. Plotting it on the number line, minus 3 will be here, and of course, it's a hollow point. So the domain for the exponent goes from negative infinity to minus 3, open, union, minus 3, open again, to positive infinity. And as in previous cases, the domain of f of x is the intersection of both domains. From negative infinity to minus 3, union, minus 3 to 1, union, 4 to positive infinity. We're done. I hope you've had a lot of fun with functions. I've just noticed. The title was covered by a tool. Anyway, if you got any questions, leave me a comment. Thank you for watching and see you soon. Bye.